Hey guys, I thought I'd show off the code for the app that I made, the Black Desert Failstack calculator, and kind of give people an idea as to how the app works and how it calculates how many failstacks that you should use. So basically, if you get to it, after it checks to make sure the user's input is valid, it starts a loop. And basically, it'll calculate what it costs for pry, and then what it costs for duo, and then try, and so on. Because you need to know the cost of the one before it to know the one after it. In some cases, for example, if you want to know how much it costs to get try, you have to consider the cost of getting duo, because if you fail try, it goes back down to pry plus 16, and then if it does that, then you have to get back to duo, and that costs money. So you kind of have to consider the cost of what it takes to get back to where you were if you fail, and that's a part of it. So anyway, you start the loop here, and basically it starts at 0, so you have a while loop, and then and then that while loop is a for loop, and in the for loop, basically what it does is it determines the probability of you getting to a given amount of fail stacks based on the path that the program decides to take. So in this case, we calculate the probability of if you're of a plus 14 piece of gear, succeeding or failing, and the same probability as if you used a duo piece of gear to fail stack. And then it passes that on as a parameter to the useDuo function, which I have down here, which basically determines, alright, so this is the useDuo function. So basically in the useDuo function here, it calculates the probability, it calculates the probability, and then on top of that it calculates the opportunity cost. And what that basically is it calculates, okay, if I fail this, what do I lose? You would lose all the fail stacks that you created, and when you think of that, you have to think, okay, how much does that matter? So that's weighed into the calculation, the opportunity costs, as well as the cost of the actual stone to add the fail stack. And so basically what it does to decide if you want to use duo, it says, okay, if the opportunity cost of if you fail based on the probability of failing divided by 4 is less than the opportunity cost of you using plus 14 and then the Blackstone for that, then you're going to use it. And the reason you divide it by 4 is because you get more fail stacks for using a duo. So basically you want to decide, is it cheaper to fail stack with a duo at this point in time, or is it a waste? And that's basically what that function does. So if we go back up here to when the function is invoked, it'll decide. And then if it decides to use the duo, it will set the probability to duo, and then basically it'll change to the cumulative probability. And basically what this is if you fail, I think it's I don't know what it's called, maybe it's a permutation, but basically if you fail the enchant, how do I describe this? With each enchant, basically, you have a lower and lower chance of each enchant working in a row, so you have to multiply the probability each time to see what the cumulative probability is. And so you do that, you add 3 to the loop because you added 3 fail stacks, and that's what happens there. And if it's already made the transition for duo, then this part isn't done, but if it hasn't, this kind of records when it was the time to switch to duo so that I can feed that to you later. And then if it decides not to use duo, which it probably will the first 20 or so times depending on the market, then it uses the probability of plus 14. It does the same thing with the cumulative probability. And then you see on both functions it adds the costs of the Blackstone to your cumulative cost of getting to that amount of fail stacks. And then after it gets through that, basically what I have here is I calculated that on average, if you're going for an infinite amount of fail stacks, you on average don't use more than 11 or so Blackstones, so I capped it at that. There might be a more effective way to do this, but I mathematically could not figure it out, so this is the most accurate thing I could think of. And anyway, so it does that, and basically it calculates the cost of failstacking, also known as B-stone fee, as the number of Blackstones per attempt times the cost of Blackstones divided by the cumulative probability. And then, okay, so then you go on, and then it calculates the probability of your enchant succeeding. It's called ACTProb because this is originally only for accessories, but I've changed it. And that basically is so that's the base probability plus what the fail stacks give you basically. So this is the bonus per stack times the amount of fail stacks. And then here you see you have like a bunch of if-else statements. So for the 0, this is for if you're going for pry, and duo is also the same. Just they look a little bit different, but they're the same. And basically that's just the cost of the Blackstone divided by the probability, and the cost of repair divided by probability. I probably could have fit that in one. And then you add on the cost of the Blackstone. But if it's not prior, if you're not going for prior duo, then you have to take into account the one before it, as I said earlier. So then you have all of that, but then you also have the finalized cost of getting the one before it divided by the probability of failure, because if it fails, then you lose all of that. And so you go on, and basically if it's cheaper than the cheapest value recorded so far, you record it as the optimal amount of stacks for that given enchant. And then these values get reset, and then basically once the program keeps looping trying to find the best value, and it does, and then when it does, it recalculates it in this for loop here, and doing basically the same thing to confirm it. And then yeah, this is kind of the same code here being reiterated. And then basically this code here is basically grammar, so how it instructs you to do the fail stacking. Oh, and I didn't show the getRealProbability function, but basically it does that. Honestly, this is a pretty bad explanation of how my code works. I'm sure someone else could explain it better, but that's basically the gist of it. For those of you that actually do code, I will probably post the code somewhere so that you can mess with it, or if you have any suggestions on how to improve it, you can let me know and I'll do my best to improve it. There's also the JavaScript version of the code on my website, which should be up shortly. And anyway, I just thought I'd show this, so thanks.